Traffic. It's got to be one of the most frustrating parts of modern city life, right? But what if we could make it, well, a whole lot smarter? Today, we're going to dive into a really cool breakthrough in traffic management that combines two powerful AI technologies to finally get our cities flowing again.
You know that feeling? We've all been there. You're just sitting there, staring at a red light on a completely empty street. It feels kind of ridiculous, but that little moment of frustration, it's actually a symptom of a massive citywide problem.
And that problem is urban traffic gridlock. I mean, it's not just an inconvenience. It costs us billions in lost time, wasted fuel, and the crazy part? A major culprit is the very system that's supposed to prevent it, our traffic signals.
So here's the core issue. Most traffic lights are, well, they're kind of dumb. They just run on a simple, rigid timer. They can't adapt to what's happening in the real world. You know, a sudden downpour, an accident that snarls everything up, or a concert letting out. Nope, they just follow their pre-programmed schedule, which leads to all that massive, frustrating inefficiency.
So to fix this, we need a system that basically has two distinct superpowers. First, it's got to be able to predict what traffic is going to look like in the near future. And second, it has to use that prediction to decide on the absolute best action to take, right here, right now.
All right, so let's meet our first hero in this story, the predictor. Its technical name is the common filter, and its superpower is seeing right through the chaos of traffic to get a clear, super accurate picture of what's really happening on the road.
But here's the challenge it's up against. The data that comes in from traffic sensors, you know, the cameras or those loops in the pavement, is often a complete mess. It's noisy, it's incomplete, a camera might miscount cars because a truck is in the way, or a sensor might just fail altogether, and you just can't make smart decisions with bad data.
So how does the Kalman filter solve this? Okay, think of it like a pair of noise-canceling headphones, but for traffic data. It takes all those messy, unreliable sensor readings, and using some clever math, it smooths them out. It estimates the true state of traffic. It turns this incomplete, noisy picture into a clear, reliable one. So once we have that crystal clear picture of the traffic, we need someone to actually make a call. And that's where our second hero comes in, the decider. This is a form of AI known as reinforcement learning. And believe me, this is the brains of the whole operation.
Now, what's so cool about reinforcement learning, or RL, is that it learns by doing. It's not like other AIs that need to be trained on some huge pre-existing data set. No, RL actively experiments with its environment. In this case, the traffic network, through good old trial and error. It's constantly trying new things to figure out the best strategies to cut down on congestion.
To make this a little more concrete, let's just look at the terms here. The agent, that's our AI traffic controller. Its environment is the entire traffic network it's managing. It's always looking at the state, like how long are the keys of cars at this intersection? Then it takes an action, maybe extending a green light by 5 seconds. And if that helps, it gets a reward, which is a reduced waiting time for everyone. That positive feedback reinforces the good decision.
Now this is where the real innovation kicks in. I mean, having a great predictor and a great decider is one thing, but the magic happens when they team up, creating this continuous adaptive feedback loop that just gets smarter and smarter over time.
So check out how this smart loop works in real time. Step 1, collect. The sensors are out there grabbing all that noisy data. 2, predict. The Kalman filter cleans it all up, creating that accurate picture. 3, decide. The RL agent sees that clean picture and chooses the smartest action. 4, react. The traffic signal changes and the cars on the road respond. And 5, learn. The system gets a reward for a good decision and the whole cycle repeats, getting a little bit smarter every few seconds.
So, what's the big takeaway from all of this? What's the road ahead look like? Well, we're really looking at a fundamental shift in how we manage the very flow of our cities.
So the real insight here is this incredible combination, this winning team. You've got the Kalman filter acting as the sharp-eyed predictor, giving the system a perfectly clear picture of reality. And then you have reinforcement learning as the strategic decider, making intelligent choices based on that picture. Together, they create a system that doesn't just follow a set of rules. It truly responds to the living, breathing pulse of the city.
And that just leaves us with a really fascinating thought, doesn't it? This isn't just about shorter commutes. This is about creating responsive, truly intelligent urban environments. So, if we can successfully teach our traffic signals how to think, what other parts of our cities are ready to learn?